Hello everyone, welcome to aplusbi. This channel is all about complex numbers, and in this video we're going to be solving a system of equations. So the absolute value of z is equal to 2 times the square root of 3, and the argument of z is equal to pi over 3, which is also known as 60 degrees. So we're given two things about z, and we're going to be solving for z. And I'll be presenting more than one method, possibly 2 or 3 ways to approach this. But let's start with the first one. Now, since the absolute value of z was given, I'm going to write z as a plus bi. This implies that the absolute value of z is the square root of a squared plus b squared. So from here, I do get something nice because I can set the absolute value equal to 2 root 3 and then square both sides. That's going to give me a squared plus b squared is equal to 4 times 3, which is 12. That's how you can square a product like this. Okay? So I got one equation. I do need another equation to be able to solve for a and b. And that comes from the argument. But when you think about an argument, what is that supposed to mean? So if z is equal to a plus bi, then obviously the argument of z is going to be the angle whose tangent of theta, and in this case theta is the argument of z, is going to be b over a. This is the general form. Of course, we can also use tan inverse or arctangent, but you got to be careful with that because there are two angles between 0 and 2 pi whose tangent equals a given number. You also have to take care of the quadrant. Okay? For example, if a and b are both positive, then tangent theta is going to be greater than 0 if they're both positive. And that would mean you're in the first quadrant. But a and b both can be negative, and in that case, tangent theta would still be greater than 0, right? And then you would get the same value, but you would be in a totally different quadrant. So you got to be careful with that. That's why, I'm going to give you a little bit more details on that one. So, but in this case, it's kind of easier because we do know what theta is. Imagine we didn't, and we had to look at all the cases. I mean, 2 cases only. So theta is pi over 3. So now tangent pi over 3 is going to be, as you know, square root of 3. And that's equal to b over a, right? By definition. And how do I prove that? How do I show that this is actually tangent? Because if you graph any complex number on the plane, you're going to get two things, the absolute value and the angle theta it makes. And obviously, tangent theta is given by b over a. Of course, you don't have to be in the first quadrant, but that's just the representation. So this is another good equation that we can use. It's actually very helpful because we can go ahead and write this as b equals a root 3, and then we can square both sides, or we can just plug it in here because we have another equation, and now this is a good system. Let's replace b with a root 3, okay? That gives us a squared plus a squared times 3 equals 12, or 4a squared is equal to 12, or a squared is equal to 3. Now this gives you two solutions. That's why you have to be very careful. This is a little tricky in that sense. A is either root 3 or negative root 3. Make sense? And if a is equal to root 3, then obviously b is going to be root 3 times that, which is 3, or negative 3. Now let's take a look at both of these cases, and then we're going to go ahead and conclude with the solutions. Now, first case, which is this one, gives us z equals a plus bi. Remember, that's also the name of the channel, so hopefully you don't forget. Root 3 plus 3i. And let's call this z sub 1, which is kind of like the first solution or the first candidate, because we're not sure yet. And the z sub 2 is going to be negative root 3 minus 3i. Notice that for both of these numbers, tangent theta is the same. But the difference is this number is in the first quadrant, and this one is in the third quadrant. And in both quadrants, tangent is positive. But the problem is we're given that Argument of z is pi over 3. And as you know, hopefully, pi over 3 is in the first quadrant, right? Because it corresponds to 60 degrees. Therefore, you have to stay with the first quadrant, and that means this solution is only valid. Z sub 1 is valid, and Z sub 2 you must get rid of. Make sense? Okay, let's go ahead and take a look at another approach. And I know you're probably going to hate me for this because I introduced the most circuitous and longest method. But that's just what the nature of the first method is. No pain, no gain. But also, hopefully, you get to practice the formulas and some rules and properties and so on and so forth. Okay, great. So here's how the second method goes. Again, we're given two things. Absolute value of z equals 2 root 3. And the argument of z is pi over 3, which we called theta. Now, if you do know two things about a complex number, then you can write that number in polar form. What is that? It is the absolute value of z and the argument of z. Exactly what we have. This is what we just needed. So how do you write a complex number using these two things? You can write it as absolute value of z times e to the power I theta. Sometimes this is written as r times e to the I theta because we tend to replace absolute value of z with r sometimes, which could represent the radius when this is a circle. Anyways, so we have everything we need, so why not just write z? What is z? Absolute value of z is 2 root 3, and e to the power I times pi over 3. Of course, if you leave it like that, you should be fine because this is using Euler's formula, kind of like a compact form of writing it. But if you really wanted to get numerical, you could go ahead and replace, and this is where the Euler's formula is just mind-blowingly amazing. E to the I theta can be written as cosine theta plus I sine theta. Look, just try to imagine how beautiful this formula is. Now let's go ahead and plug it into this. So this means cosine of pi over 3 plus I times sine of pi over 3. Awesome. Now, from here you can do the following. Just replace cosine pi over 3 with what it is. And cosine 60 is the same as sine 30. Remember from trigonometry days. If you haven't taken it, please take a look. Basic trigonometry actually is pretty easy, but now it gets a little bit more complicated. Cosine 60 is sine 30, which is 1/2. And sine 60 is cosine 30, which is root 3 over 3. That's how I actually remembered when I was in 10th grade. I think that's when I took trigonometry, or it was part of some algebra course, whatever. Now distribute the 2 root 3. You're going to get root 3 plus 3i, because 2 is going to cancel out, and root 3 times root 3 is 3. So that's the only solution that comes up from this, because there's only one solution to this equation. Make sense? Okay. Hopefully this made a lot of sense. We could also talk about a third approach which uses sine and cosine, but I think this is good enough for today. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.